everyone, my name is Nalin, and today I'm going to present this paper named Teachable Conversational Agents for Crowdwork, Effects on Performance and Trust. This work was completed at the University of Waterloo with Joslin Go and Professor Edith Law. So our work is mostly motivated by an intriguing quest of fostering human-AI collaboration through teachable agents. Interestingly, this particular area has been explored across multiple research disciplines such as computer science, educational research, and psychology. For instance, for past several years, computer science researchers have worked on areas like interactive machine learning and machine teaching that involves humans in the process of building machine learning systems. Likewise, educational researchers have extensively leveraged a psychological phenomena called protege effect that suggests that teaching others can be more effective than self-work. This basically implies that teaching a task has greater benefits than individually performing the same task. So the primary question that we aim to address through our work relates to the feasibility of combining these two approaches and examining the efficacy of teachable agents in the context of crowdsourcing. Our focus on previous work is essentially pivoted around the research on teacher-learner interaction, techniques to improve crowdworkers' performance, and studies related to concepts of trust between human-computer collaboration. Teacher-learner interaction is a well-studied area across multiple disciplines that focuses on the mutual impact of teachers and learners on each other. Computer science and machine learning communities have explored this under interactive machine learning techniques such as active learning and machine teaching. Active learning aims to improve machine learners' performance by actively querying a human oracle and obtain labels. And machine teaching seeks to create optimal training set from humans that can efficiently guide a learning algorithm. While most of the computer science researchers study teacher-learner interactions to optimize the training outcomes for learners, educational researchers explore this interaction form from another perspective, which is based on learning by teaching techniques such as reciprocal teaching and peer-assisted tutoring. Under this theme, several studies have demonstrated the effectiveness of protege effect or learning by teaching for cognitive, metacognitive, and motor learning skills that are evolved from the expectation to teach others. Now, this theme of improving performance is also very common in crowdsourcing research, where researchers have explored techniques to augment crowdworkers' performance in human intelligence tasks. This has been investigated through monetary techniques such as increasing the magnitude of reward, perceived fairness in pay, as well as non-monetary techniques such as implicit or explicit training, peer review, and use of intrinsic motivational drivers such as curiosity and interaction with chatbots. But in any form of interaction, one of the most fundamental component is the element of trust between the entities, which has been extensively studied in human-AI interaction. Chatharaman and al. Found that adding visual presence to an agent on a shopping website increases participants' trust. Likewise, Wang and al. Found that transparency of a system increases cognitive trust, and Lim and al. Found that trust can also be improved by providing different types of explanations. While all of this forms the backbone of our current work, it is still different in the sense that we explore teacher-learner interaction in the context of crowdsourcing. We validate whether this interaction technique can be used to improve crowdworkers' performance. And finally, we substantiate whether this influences the dynamics of trust between human-computer interaction. Now, we achieve all of this through a modified crowdsourcing workflow where crowdworkers teach human intelligence tasks to a teachable conversational agents through conversational interaction. This is different from traditional crowdsourcing workflow where crowdworkers perform the task themselves in exchange for monetary compensation from requesters. So we performed two experiments. The first one was focused on validating the effect of learning by teaching in the context of crowdsourcing. For this, we recruited 100 participants for a between subjects crowdsourcing study. Half of them were asked to perform a text classification task themselves, and other half were asked to teach text classification to an agent. All participants performed a pre-interaction and post-interaction baseline task before and after their respective experimental conditions. Towards the end, they also filled an IMI activity perception questionnaire. Estimated completion time for the entire experiment was 20 minutes, and all participants were compensated well above the US federal minimum wage. So the results of the experiment 1 were quite encouraging. It was found that participants who taught the task to their agent exchanged more information and performed better in the post-interaction tasks than those who performed the task individually. Further, results from IMI Activity Perception Questionnaire revealed that participants who identified themselves as teachers found the task more useful and valuable than those who identified themselves as mere annotators. In the second experiment, we investigated the dynamics of trust within teacher-learner interaction between crowdworkers and the agent. For this, we recruited 80 participants for another between subjects crowdsourcing study, where half of the participants taught their own agent during the task and other half interacted with a pre-taught agent. After the respective experimental condition, participants were presented with a bonus task involving more text classifications. Participants could either skip the bonus task entirely or select a portion of the task for the agent as well as for themselves. In the end, all participants filled a trust measuring questionnaire. Estimated completion time for this experiment was also 20 minutes, and all participants were compensated well above the US federal minimum wage. So the results of second experiment were also very intriguing. We found that participants who taught their own agent delegated more tasks to the teachable agent as compared to the participants who interacted with a pre-trained agent. Finally, after reviewing the trust measuring questionnaire, we found that participants who taught their own agent reported more trust on automated systems and were more confident in themselves as their own ability to do the same task. Overall, this work demonstrates that teachable agents are useful in crowdsourcing and improves trust in human-AI collaboration. All the supplementary data related to this work is available on the project homepage. For additional details and experimental results, please see the accompanying paper.